Hi, everyone. Yes, I'm Thomas Holterbach from the University of Strasbourg. I'm a postdoc there. And today I will show you our last findings while I was a 2023 Manners Ambassador. So this will be about BGP routes collection and how to better prevent routing attacks such as BGP hijacks. So the main outcome of the last few months is a system to detect BGP forged origin hijacks. So just a quick reminder about what are those hijacks. So we have a little scenario on the right here. This is a nice level topology where there are a few autonomous systems. And we can imagine now that IS6 announces a prefix 6/8. So all the other autonomous systems in our topology can now reach this prefix thanks to BGP. So we can also imagine now that IS5 is an attacker and performs BGP hijacks to divert the traffic that is originally destined to the prefix 6/8. So the attacker hijacks 6/8. And when the attacker does so, it actually pretends 6 to the IS path. And when it does so, the origin of the route, the malicious route, is actually valid in this case, which means that from a BGP standpoint, the hijack route actually appears legitimate, and mechanisms such as RPKI and ROV will not work in this case. Okay, so those attacks actually happen frequently in the wild. And what we did is we designed a system which can detect those BGP hijacks using a probabilistic algorithm. And this is actually published at NSDI. We will present it next year. So we also have a website actually where you can find the papers already, and you can also check the suspicious cases that our system has detected. So if you're a network operator, you can go on the website and check whether, for instance, your network was targeted by such hijacks. Keep in mind that there are still some false positives, of course, but not many. So you will be able to check whether you have been targeted by hijacks using some filters, for instance. So this is doable now. So we can, yeah, thank you. So more recently, we actually did some other findings. And something interesting is that we realized that the quality of the detection highly depends on the coverage of the BGP route collection platforms. Okay, so here I'm talking about RIPERIS and RoutViews. I'm sure you are familiar with those platforms because they are extremely used by researchers and operators. So how they work quickly, they have BGP collectors that actually peer with BGP routers. And those BGP routers, which I call vantage points here, VP1 and VP2, they export BGP routes to these collectors, and these routes are then stored in a database such that user can process them for measuring internet routing. And now if you imagine that there is one vantage point in AS1 and another one in AS2, well, then the hijack would be detected because vantage point 2 is located in AS2, which actually sees the malicious route. Now, if you imagine that VP2 is actually located in AS4, well, in this case, we would not be able to detect the hijack because VP2 is located in AS4, and AS4 uses the legitimate path, VP1 as well. So the hijack would just be would be uncovered in this case. So we actually measured using simulations the hijack observability as a function of the coverage of the BGP route collection platforms. So here on the y-axis, you have the percentage of autonomous systems that host the vantage point from 0 to 100. And on the y-axis, we have the percentage of hijacks that go completely unnoticed. Unnoticed means that no vantage point actually see the hijack. So this is the result. So you can see that overall, it looks that the number of hijacks that are completely unnoticed is rather low. But the problem is that today, there are only between 1% and 2% of the ISCs that host the vantage point, which means that roughly 20% of the hijacks, I'm talking about forged origin hijacks, by the way, here, are completely unnoticed, meaning that even if we implement the best algorithm to detect them, even if we use all the recent RoutViews vantage points, we will miss 1/5 of the hijacks. So this problem of vantage point coverage also impacts other measurement studies. For instance, if you want to map the internet highest level topology, which is a very common goal among researchers, you will also have problems here. For instance, now what we want to look at is the percentage of ICE links that go completely unnoticed. So this is the y-axis here. And then we divide peer-to-peer links and customer-to-provider links. But when you look at the peer-to-peer links, you can see that with between 1% and 2% of autonomous systems that host a vantage point, you will miss between 70 and 80% of peer-to-peer links. So this means that probably today, when we build the highest level topology, when we map the highest level topology, we're probably missing the majority of the peer-to-peer links. Recently, we proposed 2 frameworks to mitigate the risk of missing useful BGP routes. So first, we propose a system that is called MVP, and which aims to find which vantage points export the most useful routes. So I have presented this system already last year at RIPE, and now it is under submission. And we also propose a new route collection infrastructure that is able to host an order of magnitude more vantage points. So this will be actually presented today in a few hours at Hotnets 23. Thank you.